find the day of the week on any day by me, Jensen Chen. Over here at UCSD Celebrate, I was in my dorm and was partying. How did some people actually know what day of the week it was on any given day? I thought to myself, this had to be a math problem, so I got to thinking. In around an hour, I came to my solution, and I want to show you my step-by-step thinking and progress on how I got the steps in order to find any weekday mathematically. So with any problem, we must ask, what is it that we need in order to solve this problem? We must break this problem down into smaller problems so that we may answer this question. So, the big question is, what do we need in order to find random dates? What do we need in order to find random dates on weekdays? Let's think. Now I had a feeling that one could not simply blurt out a random date and that somehow is correspondent to a weekday without having a reference date. Or more rather, if I wanted to answer the big question, I must ask a little question. What day was it last week? What day was it last week and one day? What day was it exactly 1 year ago? And it dawned on me, or at least how I'm going to solve this conundrum, is we need a reference point. If I know some day was a Monday, and 7 days before or after that day must also be a Monday. So a reference date is the starter for how I'm planning to solve this problem. Second, obviously, is that every year has a set of weekdays from other years. They're all different. Last year's birthday is not on the same weekday as this year's birthday. So we must find out how many days does each year show. Obviously, there are leap years, but we will consider that later on. Reference date. So we'll use the day of today, which is August 13, 2026. That is a Thursday. And we're going to try to guess or solve what date is on March 14, 2008, or Pi Day. So let's quickly do some math to find out how many weekday shows every year. We can do this by dividing 365 days by 7 days a week. Let's calculate. 365 days with 7 days a week. That is 7 divided by 365. That's equal to 52. And we see there is a remainder of 1 at the bottom. That represents an extra day. Using remainders, we can see that the 1 at the bottom is the remainder that signifies the shift every year is by 1 day. Whether that 1 day forward when looking for the weekday of 1 year ahead or 1 day backwards 1 year behind on the exact same day. Where this is put. I hope you can see by now what I'm attempting to do. By knowing the shift in weekdays every year, we can use that to predict where our guess day will be. But before we can get to the guess day, it would be easier for us to find the reference date of the week at the same year of the guess year. So in our case, we will be going from Thursday, August 13 to August 13, 2008. We're using the shift in our favor to determine a new reference date, but now in 2008, so it becomes easier for us to find the weekday of dates within the same year. It's like how I know 3 weeks ago, it's 21 days, so around July 23rd, which was also a Thursday. Leap years. So with all the logic out of the way, let's actually mathematically solve this problem. 2026 minus 2008 is 18 years apart. But there's a catch. There's also leap years to consider in between. We know leap years have an extra day, and by doing the math, we can see the shift is now 2 days instead of 1 day of a shift every year of a normal year. Good thing for us though is that there's one easy extra step when considering leap years to put into our solution. The loop. I want to introduce you guys to what I call the loop. The loop between Mondays through Sundays. This loop is what dividing by 7 and getting the remainder represents. Every remainder is a next step or an index from the 0th term, which is our reference date. If our remainder is 0, that being clearly divisible by 7, it will always land on the same day of the week. Well, for our case, since we're going backwards, our remainder 1 through 3 are days of the week before Thursday, and 4 through 6 are days after Thursday. Back to the 18-year gap between days, we know if there are no leap years, we should shift by 18. But considering the leap years, all we need to do is add the additional shifts to 18. To do that, we either count how many leap years are in between days, excluding the leap years if it's on a leap year before the month of March, or if the year gap is too big to count all the leap years, we can just divide the year gap by 4 to find all the leap years in between. You can do this because all the leap years is every 4 years. So to find all the leap years, dividing by 4 gives you how many 4-year jumps that have been in between the 18-year gap. Now doing the math, 18 divided by 4 equals 4, and then there are bits that we do not need to consider. Now what we do with this 4 is we add it onto the 18, so then we'll be getting 22. 22 will be the amount of shifts total between 2026 and 2008 in weekdays. Going back to our loop, we know that we have 22 shifts. We can either by hand count 22 following this loop, or we can mathematically find the number index. As you can see, there is no 22 here, but if you follow and count the arrows 22 times, you will land on the correct index. But you can mathematically solve it so you can get the index number. Calculate the loop of shifting. What we do is divide the 22 weekday shift by 7, and we get a 1 day shift total. Since we're going back in time, the remainder 1 represents going back 1, or referencing the loop, the index 1, as we can see the 1 represents Wednesday, which is what the calendar says it would be. As you can see, 2008 on August, 1 represents a Wednesday, and we see that 2008, August 13 is a Wednesday, while August 2026 today is a Thursday. Now that we're in 2008, the final step is much simpler. Remember your days of a month, this should be a lot quicker. So currently, August 13, 2008 is 13 days away from July, or July is 31 days from June, and so on and so forth. March 31st is 17 days away from March 14. Adding all these numbers together, we get 152 days. This is the total days from August 13 to March 14. We're finding the total days away in order to find out how many weeks away August 13 is from March 14. So let's calculate it. How many weeks away? Doing the same math as before, we'll find that we have a shift in 1 weekday from 2026 to 2008 of August 13. We can see that we get a shift in 5, or an index 5 of the new loop. Onto the new loop, we can see that 5 is a Friday, which is correct on the calendar of March 2008. March 14, a Friday, is in fact on a Friday. Don't let symbols discourage you. This is the expression I came up with for this problem. This notation is a bit random, but it is what I put when I was looking for the solution of this problem. You should use this expression with careful consideration as it does not fully encompass everything. For example, when thinking of a date ahead of your reference, the remainder should go forward, not backwards, like in this example for the loop. This is just something you should consider when using this expression. Not only this, but chosen leap years that are not fully accounted for, as you need to be careful about leap years on January and February. You may need to subtract by 1 of the total expression if it's before February 29 on a leap year for your chosen year. So this expression gives you the shift in days of the original loop of your reference date, your first reference date. We can go over the terminology here. YD is equal to YR minus YC, which I would call the year difference. YR being the year of the reference, and YC is the year that you chose. DRMD equals DRM minus DMRL is day reference month difference. It is the distance between the days that we calculated just recently, where DRM is day reference month and DRML is day reference month left. That would essentially be when we're doing August 13. There's 13 days of August, so the month left would be 0 and DRM would be 13. If we were going ahead, say the reference day, say the chosen day was in September, then DRM would still be 13, but DRML would be 31 days because August has 31 days, and we need to reach September using DRMD or day reference month difference. Day chosen month difference, or DCMD, is similar to the R&D, where it is how many days are left or chosen for the how many days are left for the chosen month. In our example, that was in March 14, DCM, which is the date chosen month, would be 14, and DCML is day chosen month left, and that would be equal to 31 days. So DCMD would be how many days left until we reach to the 14. Now DIM, or day intermediate month, are all the days of the month total between the 2 months of the chosen in reference. I hope you can see how we've used these variables to solve this. Now I'm going to go over each term of this expression to show you how each term came to be and how I showed you these steps where these terms come from. So YD %7, that is the year difference divided by 7 with the remainder as the solution for that term. The percentage isn't multiplying anything. I didn't do this step or show you this step because I combined it with the second term, which is YD divided by 4. But in my original solution that I did not show, the solution I showed is a more simplified version of when I came up with this solution, with this expression. But originally, say we had 18 as the year difference, you would divide by 7 and get the remainder, and then you add it on to the year difference divided by 4 for the leap years, and then that would be what you had for the shifts. But I realized that dividing by 7 was redundant, so you could have just added the leap year and the year date and then divide by 7 afterwards. But either way, I showed you the step of finding the year difference and then adding the leap years in order to get a shift. So like I said, the second term, year difference //4, that double slash just means round up to the nearest whole number, so that's just accounting for the leap years. Then DRMD, we know, is, I explained it earlier, the year difference from your reference date, and then you're adding it by the days from the chosen date plus the in-between date. And the reason why it's all encompassed by mod 7, we would call it, or divide 7 and remainder, is that each of these terms individually could have had this mod 7, but I simplified the equation so that it would only have it on one side of the expression. Now obviously, like I explained earlier, you don't need to do with the first term mod 7, you can just leave it as is, with just YD plus YD divided by 4 rounded up, and then add all the days in between. If you put the information for the example today, YD being 18, DRMD being 13, DCMD being 17, and DIM being 122, If you add it all up, your answer should be 6. If you look at the loop, this is the original loop, so not the shifted new loop I showed earlier in the steps. 56 is a Friday, which is correct. March 14, 2008 was a Friday. So thank you for listening. Thank you for listening. I've worked hard on making this presentation and finding a solution. I did not use any assistant tools. I found thinking about it on my own without assistance and training my brain for logic was the solution I needed for myself and for this problem. So again, thank you for listening.